and yet are also the thing that causes so many problems and memory leaks and things like that. So pointers are a lot of fun, a lot of power, and a lot of problems. If you don't know what a pointer is just an integer that contains what? An address. Burn that into your memory.
A memory address, right?
Pointers, yes, a memory address. Pointers are always just an address. Okay? Anything could be at that address, but a pointer by itself is just an address. All right, and so basic pointer, we could have a number here. I'm going to give this value of 5 or 55 as it came out. And then I want a pointer. I'm just going to call it PTR. And this pointer can point to any integer. It is an integer pointer. In fact, it's better to think of it like that, as in this is the data type. It's not an int, it's an int pointer. And we could have a string pointer, or we could have a hero pointer. But think of it as a data type. These are all just integers containing some address. No matter what type of pointer it is, it's just an integer containing an address. So if I want this pointer to point at my variable num, I can set that equal to num, and this does not work. Why?
Because you're supposed to use the arrow pointed to the num.
Not the arrow.
The address of or whatever.
Address of. The ampersand. The address of num, because a pointer always stores an address. And so if we do a cout for num here, and then we can do a cout for the address of num. And then we could cout PTR. And you could even cout the address of PTR if you wanted to. Not overly important. But if you run that, you should get 3 different numbers. So to cout num, we get what we would expect. We cout the address of num, we get an address. And then if we display PTR, we get the exact same number. That just shows that the value of this integer is the address of that variable. And then, PTR has got its own address. So there's the basics. The pointer is an address. Now, if I want to access the variable at that address, how would I do that?
Arrow.
Not an arrow, not yet. We have something called the dereference operator. It's an asterisk. It looks like this asterisk up here, but it serves a different purpose. It serves a third purpose when we use it for multiplication, so don't get those confused. This is going to be the dereference operator. We can dereference that pointer, and that tells the computer, I don't want the address, I want the value at that address. So you should see the same thing for dereferencing PTR that you would see for num. So I should see what? 55. Maybe. Hopefully. Yeah, so we get our 55 down there. So if you need to access the variable at a certain pointer, you dereference that pointer. And you can do it for reading or writing. Any questions on that? Do we understand this so far? Now, let's make a class. We'll make a hero. We'll give him some stats. And I'm going to make a hero pointer. So I can create a hero. All right, let me backtrack just a second. Why do we need pointers? Why make life difficult? Like, why not just do it the way we've been doing it?
Memory space?
Yeah, the memory. So in our program, Visual Studio allocates 1 megabyte of space, and we call that the stack, for all of your variables and your program. And every variable here has a name, it has an address, and it has a value. So, you know, num could be chilling out here. It had its weird address, we'll just say it was 100, and then it had a value of 55. And then we had PTR, and it had an address, we'll say it was at 104, and it had a value. What was its value based on this? 100. What? It was the address of num. Okay, so this is 1 megabyte. What if we want to use something in our program that's bigger than a megabyte? Let's say we want sound. Let's say we want, you know, 4K textures, stuff like that. How does that work? There's 32 gigabytes of RAM in these machines. We get 1 megabyte for our program. If you want to use the rest of that, it is called the heap, and it's just a big ocean of memory out there. It's okay. Your program will manage this 1 megabyte stack all by itself. It will keep track of these variable names and their addresses and their values, and if you need them, it will find them quickly because it can navigate this stack. But it cannot navigate 16 gigs, 8 gigs, 32 gigs of RAM in a timely manner. Okay? So if you want to use that memory, the rest of the memory on your system, you, the programmer, have to manage that, and that is what a pointer does. We can go out here and allocate however much space we want, megabytes of space for our audio, our 4K textures, our large files, and whatever, as long as we keep track of it. So we'll allocate some space here. We'll put PTR2 in here. It has an address not important, but the value of this pointer will be whatever we found out there on the heap. We have the stack, we have the heap. And this could be address 3000 or something like that. Okay, and we can use as much of that memory as we want. We just have to keep track of it. And we can keep track of a 4 byte pointer just fine on the stack. And then if we do need to access this memory out here, we know where to find it. That's why you need pointers. So let's do that. Let's say my hero does have 4K textures in here. And lots of sound. And so to create a hero is going to take a lot of memory. So I cannot create this guy on the stack and it run very efficiently, or it won't even fit on the stack. So I'm going to make a pointer, and I'll put this guy on the heap. How do I do that? Okay, here's hero 1 on the stack, here's hero 2 on the heap. We use the keyword new. Okay, new is the keyword that will go to the heap. It will allocate however much memory is needed for this object, calls the constructor, it sets up the memory, and it returns the address. It's important that it returns the address because we have a pointer here, and a pointer must be an address. So new allocates the memory needed for this object and returns an address to that object. So this is how you set it up on the heap. And this is the way you will normally use pointers. We've already seen this with SDL. Our textures are all pointers. Our window was a pointer. Our renderer was a pointer. Anything that's going to take up any substantial amount of space is going to be a pointer, and it goes out there on the heap. Okay, all is well so far? Let's see. Now, can I do this? It compiles, it will run. No syntax errors.
But it's not a pointer.
No, it's a pointer. I just.
Here, never mind.
Yeah, I said it was a pointer. I can even break it up. All right. This is fine. What I have highlighted, we're fine up until here. But when I call this line here, this is what happens. Right? Out here at hero, we've got, or out here at 3000, we have our hero from line 22. That's fine. But on line 23, I call new again. I created a new hero. New goes out here. It's going to do its job. It's going to allocate some more space. We're say at 4000 now. Sets up a new hero, and it does what? Returns the address to my pointer. Now what's the problem?
You lost track of the original hero.
This guy is still out there and we have no way to get to it. This is a memory leak. This is a memory leak. This is the bane of C++. This happens way too often. You won't even realize it. You'll just see your memory going up, your program will crash, and you'll be like, why? And the small memory leaks are the worst, because then you've got something like a game, and you play that game and you test your game and it works fine, and then you take it to PAX and you let it run all day and it starts dropping frames. You're like, what's going on? And people are looking at you like the game sucks. I won't tell you how I know that, but yeah, so memory leaks. If you don't take care of that memory, the memory leaks cause a lot of problems. If I were to put this in a loop, and you might be able to see the task manager, hold on. You all see that?
Yeah.
I don't know why Land School doesn't get along with the task manager. You see it now?
Yeah.
Okay, so over here you can see how much memory is being used. It gives you a little graph. And then if I run my program, you can see over time this starts to grow. Now, it will grow faster depending on how big the hero is. Now, I don't actually have 4K textures in there, but if I did, this would be growing much, much faster. And you can see this number right here as well. It's just going to climb and climb and climb until we run out of memory, and then it will crash.
Can you explain why it's like that? I mean, if it's one address that you skipped, why does it keep using so much memory if it's just one address? I'm sorry if that's a stupid question.
No, it's doing this every time. Every time new is called, it goes out there and it allocates space.
Oh, okay.
And it sets it up again.
Okay.
But it's returning it. The problem is it's returning it to that same pointer. And to do that, it has to let go of what it has. So now this guy's lost, and that guy's lost, and the other thousands before it were lost.
I got you.
And it becomes corrupt. And you'll get, some sort of memory error, or you'll get heap corruption errors and things like that. Or stuff just starts flickering and acting weird because pieces of the memory are missing. That's what happens when it runs out of room. Anyways, that's how you can check it. You can look in your task manager, look at the resource monitor, and watch your memory go up and down. You can also see it right here if you have this thing pulled up in Visual Studio. If this is on a steady incline, you have a problem. That should go up when you start your program, and then it should smooth out and stay stable. All right, so this is where you're going to use pointers most of all, are with objects. You're not going to, in most cases, you're not going to have a pointer pointing at an integer. You're going to have a pointer pointing at an object. All right. We're going to have an array of pointers. Come on. Let's say you wanted to make an array of pointers. You could do basically the same way. Just keep in mind this is part of your data type. With one exception, I'll show you where you can't think of it that way, but there's an array of hero pointers. Now these are all empty. These are not pointing at anything. We could set up a for loop. And say hero I equals new hero. And that would create 40 heroes. Each one has their own pointer. Instead of all being assigned to the same pointer and 39 of them being lost. That's the proper way to do it. Does anyone know how a for each loop works? Let's say Otto in hero. That's effectively the same thing. You may see it done that way. So there's an array of pointers. Any questions on that? Okay, so auto is a keyword in C++ that will automatically determine the data type. So like if you don't know what the data type is, but you do know the function call or something like that, you can just use auto. You could do that, and that will automatically determine that hero 2 is going to be a hero pointer. So it's the same thing as saying it's a hero pointer. That does the same thing.
That does all for you?
I believe so. Yes, this will run through the entire array.
Do those run faster than for loops?
It is a for loop. I don't think it would be faster. If anything, it should be slower because it has to determine.
It has to make a decision on what it is first.
If you use Otto, it's got to figure that out at some point. It may do that at build time, so that may not be an issue, but it should be just as fast, I think. I could be wrong, but I think. I wonder why it doesn't like. Oh, because it has to be public. Yeah, so it creates 40 heroes there. All right, any questions on that? You might have an array of heroes or objects, an array of objects, and just have one pointer that iterates through all of them. If I use the name of the array, it returns the address of the first element in the array, right? You guys remember that from intro? So this says one pointer pointing to the first hero in the array. Remember, arrays are all lined up in memory side by side. And then with pointer arithmetic, you can say, PTR plus plus, that'll take you to the second element. Or, that'll take you to the sixth element. Remember pointer arithmetic? Nobody remembers that. So if I say, there's the arrow you were talking about. Actually, that's wrong because this is not, those are not pointers anymore. If I say hero6.name equals Fred, and then because this is a pointer, I will have to use the arrow, but I can see out the name of whatever this pointer is pointing to. And what do you expect to see there? Is it Fred, or am I off by one?
Off by one.
Oh, I got it. But the pointer will move. If we tell it to move 6, it's going to move 6 spaces in memory over. Now, the space, the size of that space is determined by the hero. And this is just something C++ does. It can take a look at all this, determine how big each object is, and then it will scoot over that amount each time we bump it. So I say hero plus plus. If a hero is 20 bytes, it's going to scoot over 20 bytes. If I say plus equals 6, it's going to scoot over 120 bytes. So that's pointer arithmetic. Something cool we can do, you can have a char pointer, or you can have a char. Let's call it, I don't know, let's call it A. And we'll set it equal to A, and then we can have a char pointer. Set it to the address of A. And then we could set up a for loop. Actually, we'll just set up an infinite loop. And we'll see out PTR dereferenced so I should get my A, right? Over and over again? Yes? Does everyone understand this code? I've got an A. I've got a pointer pointing at A. I'm using a cout statement to display that A over and over again. But let's use pointer arithmetic to move the pointer each loop. Now what will we see? What's behind the A? We don't know. That memory could belong to an entirely different program. So this is where you learn how to hack the memory. And you see all kinds of cool stuff. You get some emojis. You can find, information from other password or information from other programs, things like that. So that's kind of cool. That's a neat thing you can do in C++ that you cannot do in most languages. All right, let's take 5 and we'll come back and look at some more stuff.
That's a great question. One's in a blue unit, mine. Like, if my team doesn't win, I'm not done. Yeah, exactly. It hurts. No, every time like I opt out. Dang, darn.
Yeah, and then the first game, my entire team died. Like him and one of our other members died.
It was the
And then one of my other friends died. And I was like, "Hey, let's do this." And he's like, "No, you're playing good." And I was like, and then
Wait, was he actually?
yes, he was playing fine. And I got really super dark with him. So I guess
Was he like
I
complaining
didn't
about it?
yeah. So I got the residence or whatever, and I got my liver stuff. And I was drinking because I was like, I didn't stop. I really think that I see how many resources I was like, I have to bring where I'm at.
Exactly, yeah.
I'm the only person who's gonna give me stuff. I'm the only person who's gonna fix stuff. Like that's just such crazy. And
I'm gonna loop when I go.
in the games we were playing, I did when I dropped it, I wasn't happy with like the last three kills just really quick.
I love those numbers.
There was just things where
You can watch it, like,
yeah, it was really good. And there's not
like,
What is that? That's gorgeous.
Wait, what? I know.
If you take the Indo off, it would completely.
Shut up. What?
I literally, we found like it has like the bomber icon.
Yeah.
I'm not kidding. I just started it.
What?
It's like an easy code.
I love it. I love it.
They're probably so cool. I took a star.
Yeah,
I did two. And I all got hundreds and.
It's still going.
But you know what backgrounds are okay? You're stacked on them.
I gotta like this forever.
So how do we do pointers and functions? I'm going to create just a void function here, and I'm going to call it the kill function. And it's going to take a hero pointer, and it's going to kill this guy off. So there's the arrow. If you need to access the members of a class through a pointer, you use the arrow instead of the dot. So hero HP equals 0. See out. I don't know, we can see out. Or something like that. And now if I wanted to I can call that function, I can pass in my hero, and he will die. Right? Simple enough? Where? Oh, he doesn't have a name. That's unfortunate. Bob?
Yeah.
Okay. I could do this. I could say name equals Bob. Another way of doing this is with an initialization list. Alright, so I could put this up here and say name, open close braces, and I can put Bob in there. Either way works. This is slightly faster. Nothing you will ever see or notice, but technically if you get down to the nanoseconds, that is faster. Alright, so now let's see if Bob dies. Yes, Bob has fallen in battle. Good. Our function works just fine. So if you want to pass a pointer, you just tell it what type of pointer it is. This is a hero pointer. And that works great. Now, what if my hero was created on the stack? Let's say it fits on the stack, we create it on the stack, there's no pointer. But my function requires a pointer. How do I deal with this? Without changing the function, first look at the error message, because you will see this at some point in your programming career. No suitable conversion function from hero to hero pointer exists. There's a difference in the data types. But remember what I said. A pointer is just an address, right? This wants an address, is what it's saying. It needs the address of a hero. Does our hero have an address? It has to. How would we send the address? We put the ampersand there, right? And we've done this in SDL. Anytime we pass those rectangles around to the renderer or the query function, things like that, you send it with the ampersand because that function wants an address. And so here's how you get around that. Just remember, a pointer is always an address. And this works just fine. I was going to show you that one thing. You can always think of the pointer as part of the data type until you declare several of these guys on one line. Now I can say int A, B, and C, right? And that's 3 integers. That works. We've seen that. But cannot say hero pointer, hero 1, hero 2, hero 3. That is not 3 hero pointers. This is the only spot I know of where thinking of this as the data type breaks down. Hero 1 is a pointer. These other 2 are just heroes. So if you want to declare multiple pointers on one line, you have to put the asterisk in front of all 3, which makes you wonder, is the asterisk really part of the data type? Because it should follow this convention if it is. But otherwise you can think of it as part of the data type. Does that make sense? Any questions about pointers and functions?
Could you show us the Bob thing that you created?
So can you do that with multiple variables?
Oh, 1 second. Don, what'd you say?
Oh, I just wanted to see how you do the faster naming convention for Bob.
This is initialize. And you can do this with all of the values here. We're gonna need a comma.
Is this used for like respawns? When he respawns, he has this much?
No, this is when he creates, or when he is created.
It's actually really neat.
This is the proper way to do it. If you want to initialize variables for a class, you create an initialization list, and then when that object is created, it sets these values like this. Now, what happens if you do them in here? What if I did it like this instead? All right, this is not wrong, and this is how you will see it done, and it's a little more intuitive for a lot of people. You know, I could do it this way. What happens if you do it this way? It creates the object, everything is initialized to garbage, and then it goes back and resets those values to what they should be. That's why the initialization list is slightly faster. But I would say more importantly, this looks good on a resume. This shows you know what you're doing. This says, you know, I'm a noob who learned C# or something. Not really. Either way will work. Either way is fine. This is just the proper way to do it. Definitely don't do both, though. So what was your question? What's your name?
Yeah, you got it.
What's your name?
Blake.
Blake. What was your question?
Can you do multiple of them, or you just do?
Oh, okay.
Yeah.
Anybody else? Last thing I can think of might be returning a pointer. You can, let's say it wasn't a void function we wanted to return. We might return an integer. We might return an integer pointer. We could return a string pointer, a hero pointer. But you can return a pointer the same way. Just remember, you know, that's your data type, and then in here, we've got to return some hero pointer. So that would be a hero pointer. Hero is a hero pointer. It got passed in. As long as I return a hero pointer, this is fine. So if you want to return a pointer, that's how you do it. All right, that's pretty much it. That's the overview, the rundown. There are other things. There are like pointers, 2 pointers. You know, I could. You can do weird stuff like that. Or wait, what is this? This got to be the address of 0, 1. Pointers to pointers. It's like arrays at that point. You can have pointers to pointers, and access them by dereferencing them 3 times and all that good stuff. But I don't recommend it. But it does exist. You can do it. We good? Everybody understands pointers? All right. Let's move on to SDL. So pull up your project from 2 weeks ago. And we just kind of review over this. Make sure we're on the same page, and then we'll pick up with some new stuff.
Are we using the lab? Or the
I recommend it. The lab. So your main should look like this. You should have object included up at the top. Has everyone got it open? All right. Should have object included up here at the top in main. We've got our initialization, our window, our renderer, some delta time stuff. I have 2 objects. Y'all should have 3. All right, and then, well, you should have a player, a bullet, and a what? Asteroid? Okay, so mine's a little bit different here. I'll fix that. Okay, so I have to include player instead of object up here. And then I need oh, that doesn't work. I've got to make a constructor. I didn't have that. String file. You guys should already have this, hopefully.
You're recording again, are you?
I am. Object. That invokes my object constructor, so I don't have to type all this out again. It sets all this up for me. Okay, so this is happy. We're good. We've got our bool for running. We have an event. We don't need selected anymore. Scrap that. We're just going to have the player, so we're going to set the player up so it can rotate and move in the direction it's actually pointing instead of, you know, just up and down, left and right. We have delta set up. We've got our quit event. All of this selected stuff can go. So take a look at that. Scan codes and the switch can go, but we do need to still call update. So player dot update delta. And then I need a player draw instead of an object draw. So that's how main should look. Is everyone close to that? Okay, we need 3 images. You need an image for the player, most importantly, so get that one first, and then if you still have time, pick an image for a bullet and an image for an asteroid. Your player and your bullet, if the bullet is directional, those need to be facing to the right. So at 0 degree angle, you want your image facing to the right. And then you should be able to run this, and you got your ship there. I'm going to change so my arrow keys rotate the ship, and the up key will make him go in the direction he is pointing. So to do that, where do we control the ship? Update? Object update? Okay, I don't want all of my objects to behave this way, so I am going to give player its own update. So let's do that. We'll override the object update. We'll pass in delta. You declare these in your header file, and you flesh them out in the CPP. You click on this little light bulb, and it will create it for you. and give you a peek window to write it out in, or you can just step back over here into the CPP file and we'll update. Now I want the code from object, so that's this constant where we get the keyboard states, and then all of my keyboard input. I'm going to leave the wraparound stuff there. I'm cutting this out. And I'm leaving the rectangle and position updates in there. But I cut out all the keyboard input, and I'm going to paste that in the player, because really the player is the only thing that needs to be controlled by the keyboard. Down is not a thing in Asteroid, so I'm going to scrap that one altogether. And then A and S are not needed. I don't know if y'all have A and S here. I'm going to use left and right to control the angle, and I'm going to use up to adjust and to move. Now we'll have to change this in a minute, but left and right should control the angle, not the position. So angle, and angle, and I will scrap these two down here. So I've got 3 if statements in my player update. Okay, he rotates. He's not moving. Why isn't he moving? Oh, that's right. I do need to update the rectangles. So these 2 lines, actually I can just call object update because I still want the player to wrap around. So let's do that. We'll just call update from the base class, and that will take care of it. But the point of doing this is so the controls don't affect the asteroids and the bullets and the other objects that we want later on in the game. That should rotate and move upwards. But of course, what we want it to do is move in the direction it is pointing. So this is no good. Position doesn't change based on minus equals speed. We want this guy to move in the direction that he's pointing. Now, this requires some trigonometry. Does anybody speak trig?
It's been a while.
Okay. Let's just say I want to go this way. All right, here's the x. Here's the y. What needs to happen here?
Figure out the angle, the direction you want.
Okay, we have an angle, right? We know the angle, so we've got this. But even without trig, what we want is we want some movement in the x and we want some movement in the y. We kind of want it even at this point if this is a 45, right? Would everyone agree with that? Yeah, we want to be moving x and y. What if we're like that? More x, a little bit of y, but not too much. All right, and to do this, this is where your trig functions come in. Your y is going to be determined by the sine of the angle, and the x is determined by the cosine of the angle. let's just plug that in. It's going to take some critiquing to get it behaving the way we want it to, but we'll start with that. So, when I push up, my y doesn't just minus equals, it plus equals speed times delta times sine of the angle. To get access to the sine and cosine function, you need to include CMath. So go to your vector and plug this in. You could do it right there in player. It doesn't have to be in vector, but pound include CMath. And then the cosine for the x. Speed times delta times the cosine of the angle. Now we have one more problem. The angle for SDL is in degrees, but your trig functions are going to want it in radians, so we're going to convert that. So what you can do, go back to your vector header file. We're going to put a macro in here. Pound define pi to be 3.14159. Don't put a semicolon on that. Directives do not get semicolons. And so now we'll convert these angles by multiplying by pi and then dividing by 180. That's what it does. You know, you could make your macro the whole thing there and just call it, you know, to radians or something like that, but that is to convert our angle from degrees to radians. So let's try that. It should move in the direction that it is pointing. Was anyone successful? Here's your code. Now let's get this working for everyone before we... Alright, that moves along, but it's real clunky. It's not very smooth. Where am I at? Okay, in player, player.cpp. Instead of position changing, we want to change velocity. And then outside of the ifs, we can update position. And if you have your overload, you can do this in one line. But position.x plus equals velocity.x I'm not sure about the times delta. I may have to come back and fix that. That may be wrong. That should give you some smooth movement. Yeah, we'll leave delta there. I think that's good. But it should accelerate now.
Oh shoot.
You should get some nice smooth movement instead of the blocky.
Mine doesn't stop now. It's just floating through outer space till an arrow against the window.
This is why it's good to have a wraparound function.
Yes.
But yeah, it's like in space now. All right, so how do we slow it down? A really bad way of doing it is to say that velocity dot x times equals 0.999, and then the same thing for y. And that will slow it down because that brings your velocity constantly closer to zero regardless of which direction you're moving, but it's not frame rate independent. So I want to come back and get something a little better for that, but it should steadily slow down. All right, I'm going to put in some different math later on to slow it down a little better, and we'll govern the speed differently. That's all I'm going to cover for today. So save your progress and wrap it up, and we'll take off again on Wednesday. There's no lab out yet, but I'll have a lab for you hopefully on Wednesday. Don't freak out about due dates, guys. If there is nothing been assigned, I don't care what Moodle says, you obviously can't turn stuff in. So some of you guys turned in something anyways. I don't know what that was, but there's no lab 4 yet.
Question. Can you reset homework 4?
Can I reset it?
You like the turn-ins, because I got the notification like 1 hour before it was due. I was like, well, I better do something. So I did something.
Okay.
That'd be cool.